Hello everybody. Today we're going to be talking about the characteristic equation of a matrix. And here we're going to be talking about square matrices. And the question that we're going to be answering here is, given a square matrix A, how do we find the eigenvalues? In the last section, we had ones where we had to see if a number was an eigenvalue, where if we knew a number was an eigenvalue, could we find an eigenvector? But here we're going to talk about just if we have a matrix A, how do we find the eigenvalues just from just the matrix? Okay. First, let's remember what an eigenvalue is. Okay, it's a real number lambda such that there is a non-zero vector, which we'll call x, such that x is an eigenvector. So when we multiply x by our matrix, what we get is just a scalar multiple of that same vector, and lambda is that scalar. Okay, so this is the type of thing that we're talking about. And we want to be able to find this lambda. Okay, so in the last video, what we did was we talked about moving this over, move the lambda x over to the other side, because we want to make this look a little more like a matrix equation, ax equals b, that we can use row reduction on. Okay, and let's think about this. So this vector x we can write as the identity times x, and then we can sort of take this vector x and factor it out on the right side. Okay, so then we've got a minus lambda I, x is equal to 0. All right, and now this is a square matrix. This is a homogeneous equation, and we want non-zero solutions or non-trivial solutions. So what we're looking for is we want lambda where a minus lambda I, the matrix that we've got down here, where this equation has non-trivial solutions. Another way to think about it is that it's not invertible, right? According to invertible matrix theorem, all the things in that list, if there's non-trivial solutions here, all the things in that list will be false. So we want where this is not invertible. Okay, so that takes our question of how to find an eigenvalue and translates it into another form. Well, how can we figure out which values this is not invertible for? Well, one way to see what is invertible and what's not is to look at determinant. Okay, and remember, a matrix is not invertible if its determinant is 0. So what we're going to do is we're changing this into an equation where we want to figure out when is this determinant 0. Okay, and this equation here is the characteristic equation. So when we talk about find the characteristic equation of a matrix, this is what we mean. Determinant of a minus lambda I is equal to 0. Okay, let's look at this with a concrete problem. All right, find the eigenvalues of this matrix A. So what we're going to do is we are going to solve determinant of a minus lambda I is equal to 0. So first we need to find a minus lambda I, and that is our matrix A, minus the identity matrix multiplied by lambda, so that's lambdas all along the diagonal. And that gives us, let's see, 4 minus lambda, 3 and 2 are unchanged because they just have 0 subtracted, and then negative 1 minus lambda. And then we find the determinant of this. So find the determinant of this, and then we're going to set that equal to 0 and solve for lambda. All right. So determinant of a 2 by 2 is not so bad, right? You multiply along the diagonal, subtract the other diagonal, not bad at all. So 4 minus lambda times negative 1 minus lambda, so that's the main diagonal entries multiplied together, minus the other entries multiplied together, 2 times 3, and we're going to set all of that equal to 0. And notice, right, this looks an awful lot, well, when we multiply it out in just a second, it's going to look an awful lot like a quadratic equation. So we multiply here, negative 4 plus lambda, let's see, negative 4 lambda, and then plus lambda squared minus 6 is equal to 0. We combine like terms, and we get lambda squared, negative 4 and 1 is going to be negative 3 lambda, minus 4 and minus 6 is negative 10 is equal to 0, and we're going to solve for lambda. And what's really nice about this is this is just a quadratic equation, okay? So when you have a 2 by 2, right, it turns out to be a quadratic equation. You can factor or use the quadratic formula. Here we are going to factor. Okay, so lambda squared, we get a lambda out front in each one, and we need numbers that multiply to be negative 10 and have a difference of 3 very conveniently. We can do negative 5 and positive 2, so that multiplies to be our negative 10. Negative 5 lambda and positive 2 lambda would give us that negative 3. And just like in college algebra, you set each factor equal to 0 and solve, and we get our 2 eigenvalues. Okay, 5 and negative 2. And that is it. So for this particular one, if we had asked just for the characteristic equation, this is what I would have put down here. Okay, the characteristic equation multiplied out with everything, all like terms gathered together, and then you go ahead and solve that equal to 0 to find your eigenvalues. So those are the eigenvalues for our matrix A from before.